When I was in F1, I already knew there were some rumors about an electric race series, and I was really interested in that. So I thought, let's give it a go, and I didn't regret it. I think it's a fantastic series.
I was really hungry to get that seat, and I think I did a good job. I really clicked with the Mahindra team, and yeah, it was quite a natural progression. And yeah, short after that, we signed a contract, and now I'm here.
In Formula E, I think the line between individual skill and technology is basically there's an overlap between both of it, because one without the other doesn't make success on the track.
The cars you see here are Generation 1 cars, so it's the first generation of Formula E cars. Next season, Season 5 that is, Generation 2 car will be introduced. So there's a lot of new stuff to be developed and tested.
So first area which we started working with Voxdale essentially is on the aerodynamic side, and Voxdale is helping us understand how this car is going to behave, like the float, the aero, the CFD, etc.
This is Nick Heidfeld's chassis, and one of the areas of development with FLOEFD was brake cooling, or I should say heating, because in this type of races it's rather a challenge of getting the brakes hot enough rather than cooling them down. These are carbon discs, so they need a lot of heat to perform well.
Well, the main thing in Formula E obviously is that we have a battery, and that's a new challenge for everyone here.
I think the biggest difference is there's a lot of unlearning for a driver, because here as the race goes on, for example, the weight of the car remains stable but the power starts coming down, while in any other conventional series the weight of the car starts coming down while the power remains constant. So that was the first thing which they had to learn. But over and above that, I think is very conscious about the energy you use, because you not only use energy but you're also creating energy. And no other championship, or even especially Formula 1 20 years ago, you never recovered and recuperated energy. I think that's something which is really difficult and different for these guys right now.
So the driver sort of has to be a little bit like an engineer in the car. And yeah, I think it's very educating, and it's very good also for I would say these guys are a little bit step ahead from the car industry, what's going to come in the next couple of years. So it's a good playground for technology.
We are developing a smart 12-volt auxiliary battery. Quite some thermal challenges with that one. We are doing full car CFD. Aero program for riding height, rake and different settings. And we are looking into thermal issues, cooling of the inverter, flow to the side pods and so on.
You have a limited amount of energy during the race, so you basically want to drive as quick and efficient as possible.
Because we cannot go flat out for all the race, we have to look after the energy. What we have to do is lift and coast. That means usually at the end of the straight, of a long straight, we have to come off throttle and just roll the car. And then in Formula E there's a special system where you can decelerate not using the brakes, but we have like a lever, and then we decelerate by putting extra energy back into the battery. And that's very important to do it at the right moment, at the right point. And this is what we are learning and looking at a lot.
Here you see the front wing of the Mahindra Racing car. The level of downforce in Formula E is a lot lower compared to, for instance, Formula 1, which makes it very difficult for the trailing car, certainly in street circuits like these, to overtake. With FLOEFD, we managed to model 2 trailing cars and see how we could optimize the settings of the trailing car to improve overtaking. We are using FLOEFD for 2 main purposes. One is aerodynamic research. So we are running now some full car CFD runs to see how it performs in the baseline and how we can improve from there. Secondly, we are doing lots of thermal stuff. In the first place, the 12-volt battery we are designing ourselves, but also cooling of the inverter, flow to the side pods, brake cooling, and all things that involve cooling aspects of the car. Next to the primary battery for the powertrain, the car is also equipped with the auxiliary battery for mission critical systems. That battery is underneath the seat of the driver. So it's very dense, very close, no airflow. Supported by Umicore, we are now designing a smart 12-volt battery for the Generation 2 car. And we are using FLOEFD to optimize thermal management of that.
Well, I think Formula E right now is, outside of Formula 1, it's like the top ladder. So I think it's a place that if you do good results, you will eventually end up here if you're a good driver.
I think the big advantage FLOEFD brought in this phase that we could already test the car before we had it, before it was built. So that's an advantage. It buys you a lot of time. Parallel to that, it's possible to do a lot of runs in parallel. You do have the baseline run, but next to that you do 10 or 20 other settings or directions you should go with your development. It's a very fast tool to use it in that way.
So we are in stages where we've started testing a new car, and I think we've understood the car better than what we were earlier when we did our previous car. So I think we are on a better stage today than where we would have been earlier. The Voxdale engineers have been with us, supporting us trackside. They do come down, etc., and work with us. At the same time, I think they've also understood, okay, the nuances of what we want in racing. And these guys have sort of stepped up to say, okay, this is a new battery coming in, how can it place? And I think what really, in this work in progress, what really excites me is the number of ideas, proactive ideas coming from Voxdale, and the enthusiasm and the management to sort of go ahead and do it. So for us, yes, that one email which came 1 year ago was a very important email.